I hope you're sitting there asking yourself, hey, wait a minute. We can't just eliminate standards, can we? We just can't throw away data like that. Well, in this case, we can because we have at least 5 standards in our calibration line. 5 standards is the minimum number that we have for statistical validity. So let's count the standards. We have 1, 2, 3, 4, 5, 6, and 7. So we do have statistical validity. Now, of course, I would not have erased those 15 and 30 part per million standards if we had a nice linear line, but we do have enough standards that we can live without them. All right, now let's turn our attention back to the results. And our first sample is the Cove sample. You'll notice that we did 3 injections of the Cove sample from tube number 1. We had an average peak area of 172, and the FIA software calculated the concentration at 8.27. So, using our junior high school math of y equals mx plus b, the peak area equals the slope times the concentration plus the intercept. In this case, we know the peak area, we know the slope, we know the intercept, and we will solve for the concentration. Okay, equals, we'll take the average area minus the y-intercept. All right, gotta put these in parentheses. All right. All right. Oops. And of course, divided by the slope. And the result should be fairly close to what the FIA calculated for us. Now, of course, we modified the standards. So we're not going to get exactly the same result, but it should be fairly close. In this case, about 20% off. We eliminated 2 of our standards, not an unreasonable change. Now, the slope and the intercept are going to be the same on all of our subsequent calculations. So let's make a modification to this formula. Okay. Now, if we have what's called a fixed reference, that is not going to change if we copy and paste the formula. The value of the slope is not going to change, and the value of the y-intercept is not going to change. So when we cut and paste this formula, we don't want these 2 values to change. So we put a $sign in front of the J, a $sign in front of the 32, a $sign in front of the J, and a $sign in front of the 31. So our column is J, our row is 32, our column is J, our row is 31, and when we cut and paste this formula, we don't want that to change because J31 and J32 are, of course, our slope and intercept values. So we don't want those to change. even if we cut and paste the formula. So let's take this formula. We will copy it. We'll go down to our next sample, sample Creek 1. And we will paste it. And again, we get something fairly close to what the FIA software calculated for us. Now, please note that I am not pasting this formula on the same line as my average. I want to have it on the row above the average. And that will become clear in a little while. Or that will become why it will become clear in a little while. Because when we erase the lines we don't need, the concentration and the calculated concentration and the sample location should line up. Okay, that makes probably no sense whatsoever now, but for the moment, just trust me, it works. And we will now cut and paste this formula everywhere we need a calculation. And so on and so on and so on. Okay, this is probably more excitement than a guy should be allowed to have, so I won't ask you to sit here. Oh, wait a minute. Do you notice that we did not cut and paste correctly? We copied and we pasted the value, but not the actual formula. Ooh, my goodness. All right, so let's copy the formula and paste special and paste the formula. And let's paste the formula. Okay, now if we highlight it, you can see that we are calculating using the average peak area, which the FIA software gave us. And no matter how many times we've cut and pasted the formula, we are still using the same slope and intercept values. So I will stop recording now and finish cutting and pasting.